Okay. And okay. Okay, it looks like I was muted there, and my microphone wasn't recording for some reason. So we'll take two. So is what it is. Not much we can do about it. The one thing I do want to mention is that what I was saying earlier, so hopefully it was muted and I'm not repeating myself. For you guys anyway, I will be repeating me. But anyway, who cares? Is the exams are a process. I know most of you have taken the exam. Few people got confused between the definition of what extending topic 2 on supply and demand and all those related topics and extending problem sets meant. The exam was not extended, but if you found yourself in the boat like a few people that you didn't bother to ask when I sent out the email and just assumed something that you shouldn't have, you can forward me an email and I'll extend out the due date on the first exam for you till Sunday. It's very important to pay attention to what the emails actually say, not just what you wish they would say. The exam was due last night, but it's not a big deal. Who cares? Secondly, when you do the exams are hand graded. The computer grading only can go so far. There's certain questions that I asked on the exam that the computer does not normally grade appropriately, or there's areas where you could have screwed up, like you put commas in or something like that. I go through and hand grade the exams. Just an FYI, I believe the highest grade on the exams possible is somewhere in the mid 80s, maybe upper 80s. I forget. It's been a couple days since I tried it out, and but it's definitely not a perfect score. You can't actually get a perfect score on the exam based on the computer grading. So it is a process. I go through and I grade all of the exams by hand and adjust up where you went right or wrong. Also, as many of you have noticed or noted, I said in the past I'll open up an exam period where you can take the exam again and do a second try to see where you can improve on your score. And I'll give you some credit for that. The goal there really is to make certain that you understand and learn the material and know how to do it. So anyway, with those kind of little things out as an aside, what I've been hoping to do is, how shall we say, show you guys some elasticity. I was hoping to get to it earlier in the week, but my schedule's fairly busy and prohibited me from actually doing something like this. Considering elasticity takes a while. And the reason we're starting earlier today is because elasticity and taxation will take a while, and I'm hoping to get through both of them. But before we start, I do want to show you, let's go here. I'm going to start showing you my screen, and what I want to do is I want you guys to be able to see some of the resources I added. So hopefully these help out. These were not written by me. This is something I actually purchased, and I'm hoping over the course of the next year to actually rewrite it. But you can see if you scroll down to study materials under Section 2, you've got supply and demand notes, elasticity notes, and government intervention and taxation. So if you're looking at these, we can click on elasticity notes. And by the way, you could go to the left column here and just find the others. But what you can do is you scroll down and you can go forward and look at what it says for elasticity notes. Now, some of the reason I want to change this is I use slightly different terminology, and textbooks do as well. This program was purchased from some guys out in Britain, actually at Oxford, and the idea behind it is, things are done differently in England versus in the United States in terms of the standardization of the way economists talk about material. But anyway, you can go through. There's a bunch of just the normal price elasticity of demand calculations and what things are. But you can scroll down here, you can see all the notes, and then you see, okay, we've got some questions as well. So if you want questions to work on, more or less I'd skip some of them, but the short answers are probably good. The essays on some of them aren't all that great. And so you could go through here and you could look at the elasticity and whether it's elastic or inelastic between 2 points. Gives you different opportunities. You can do a little self-test on multiple choice. So a cut price from $1.50 to $1.20 sees demand for a product rise by 10%. What would the price elasticity of demand be for this product, right? And so you can go through and calculate that all out using the different methods to calculate this. For this method, you'd probably want to use the midpoint formula, or just calculate the rate of change between 150 and 120, and then do quantity change the 10% over the price change, quarter pounder, so that percent change, and figure it out. But what we can see is it's going to be 0.1 on top and 150 to 0.120. Obviously, that's going to be a percentage decline. It'd have to be bigger than 10%, so it means that we're not going to have 10%. We won't have 0.1 over 0.05. That's not going to happen. It's not a smaller change, and it's not a 10% change. So these top two numbers are out, and the bottom one's out. Really probably has to be this. So let's see whether I did it. Yeah, process of elimination. Fairly simple solution there. In fact, you didn't need to calculate anything. All you really need to do is, once again, think and use some intuition, right? And so a lot of these problems, there's 3 plausible answers here and 1 clear answer. So let's see where they made it more difficult. I have no clue. Firm increases its price from 8 to 12. That's a 50% increase. Demand falls by 20%. We would expect demand to fall when price goes up. That's called the law of demand. So you're going to have Q over P, changing quantity over change in price, so 20% over 50%. So 0.2 over 0.5, that goes in 0.4, I believe, if my math is correct. And let's see. Yeah, very good. Hey, I'm awesome here. What type of good would you expect to have a negative income elasticity of demand? You believe it would be that, Nope, not that one. Maybe I should read them. So let's see. So what's it let us do? We can play with it. So anyway, you guys can go through. Has quite a few of these problems. Play with those problems. Check it out. See how it helps you, right? Let's see. So it's got other things, some short answers. As I said, I haven't played with this as much as I'd like to, so you never know. But you can see there's some other things going on here as well. So let's see. Just a sec, I'm checking, see where someone emailed me or something. Okay. So anyway, there's an article related to income elasticities of demand. You could read through that, answer some questions. That could be a good usage of time. So, especially in terms of preparing for exams. So, anyway, more things. There's a video on food crises, and if we look at the left-hand side, there's a lot of things going on here. So, anyway, some of the links you'll find are dead because, as I said, I haven't had a chance to go through and check them all out and make sure that they're okay. But obviously here they're looking for someone who has the Sunday Times password. That's not going to be us. So anyway, you can keep going on down, and you can see there's lots of little activities we could have done. Okay, and so we go down. There's also some simulation activities. Okay, so in the diagram below, shift the demand curve to the right by 15 units. Do this by clicking on the D1 label. Okay, and keeping the mouse pressed, drag it right. Note that the slope remains the same. Once you have done it, try the question below. So we go from 50 to 65. Okay. What's the value of the price elasticity of demand curve 1 when the price rises from 5 to 7 pounds? So we can go to D1, and we go when the price goes from 5 to 7. It's already labeled right here. What's the price elasticity of demand? So you can calculate that out, change in quantity over change in price, and you say, okay, the change in quantity as the price change, as the change occurred was from 5. So it'd be 25 to 15. So anyway, you guys can work through some of these if you want. This isn't required. It's just there to help you study and to give more things. This is kind of cute. So price elasticity of supply, change in quantity supplied, we would expect to see of something, and the change in the price. So we can go here, and the formula is correct. Well done. Price elasticity of demand, change in quantity demanded, change in price again. Hey, we're on a roll. So let's see. Oh, sorry, reset. Let's do it the right way. Change in quantity demanded in general, not just of one good. Sorry. divided by change in price. So anyway, take your time, go through, read them, can have some fun. Hopefully this helps you guys out, and you'll see the government intervention stuff and taxation down there. You know, my hope is that you guys work with this and it helps you. If you could let me know whether my money was well spent or not, or areas where you think it could be better written, I'll definitely focus on those first as I'm spending my coming weeks and months rewriting this appropriately. So let's get back to the matter at hand. Back to our video. Okay, let's end this, stop sharing. Okay, so we're back. We're ready to start on elasticity in and of itself. You know, I was hoping I could do this in the drawing. I'm not too fond of my little board here. It seems a little cumbersome, but at the same time, sometimes it's easier than doing anything else. You know, first or second week, or I believe it was, I tried using a drawing tablet. That wasn't too good from my perspective for me because I'm not good at drawing on a drawing tablet, so is what it is. And it looked clunky and wasn't very clear in some places when I looked at the video later online. You know, my hope is trying to get my hands on, borrow different types of camcorders to see how the sound quality is. My concern on a camcorder in doing that is that the sound quality won't be great. But if I can verify I get good sound quality without spending a couple $100 on a microphone, we'll probably switch to a classroom and I'll just have someone come in and videotape me doing some of these little mini lectures. But first up's the topic of elasticity. And I'm going to give you, let's start from the perspective on elasticity of just drawing. So we're going to do price elasticities of demand. And then I want you guys to realize once you know how to do price elasticities of demand, then price elasticities of supply are exactly the same techniques applied to the supply curve. We will talk about the different interpretation, but the math and the graphs are exactly the same. It's just the definitions, except you're applying everything to a supply curve. So we want to start with the general demand curve. So we label our graph with price and quantity and demand. And so thus far, what we've talked about when we talk about supply and demand is what happens when there's a shock to the system and this demand curve shifts. What we want to know now is not what is causing the curve to shift. We also don't want to know, well, we'll get to in a second, but we're also less concerned, we're really concerned with the price change. What we really want to understand is as this curve moves steeper and flatter, what's going to happen? What does that represent economically, right? And so the slope of the curve is what we're really concerned with here, right? We want to measure this, and I'm not going to, it's the elasticity is not equal to slope. I do want to point that out. Elasticity. Sure, we'll pretend I spelled that correctly. So elasticity is not equal to slope. I want to point that out. That's an important thing to keep in mind. But, you know, for all intents and purposes, you can think of the slope as one way of representing elasticity. And one reason we say elasticity isn't slope is demand curves aren't always linear. And so what I mean by linear is they're not a straight line. Sometimes they have curvature to them. And if that's the case, it definitely is true that elasticity isn't slope. What we're really looking at is the slope between 2 points on a line, which can vary, but with certain types of curves does not vary. So let's take the two extremes and let's talk about what these mean. So we have two possible demand curves, and let's do them in two different colors. We have a perfectly vertical demand curve and a perfectly horizontal demand curve that I've drawn here. And the question for you is, what does each curve represent or mean about the items that that we're talking about? So let's talk about what particular items, for example. So if we are talking about, well, let's talk abstractly about just good old economics stands by widgets. Widgets are made-up things that economists have used historically to talk about markets and to talk about supply when we don't want to define a good like beer or something like that. So here's our graph for two different widgets, widget black and widget red. And I want you guys to think about what this graph means in terms of the demand for widgets. So if we're looking at this demand curve for the black widget, what is this telling us? This is telling us that regardless of price, you want some fixed quantity, right? You don't care what the price is, you're going to buy the same amount. So I want you guys to think about this in terms of your own life. what types of goods do you buy where the price is irrelevant, except maybe given your budget constraint, right? Your budget's going to determine, but the price of the item, you don't care how much it costs, you're going to pay for it, even if it means you go broke. And there's not many goods like that, right? There's not many goods where if the price goes down, you're not going to stock up, and if the price goes up, you're not going to buy more. So, give you guys a little chance to think. Now I'm going to give you the answer. When we're talking about vertical demand curves, we're talking about needs more often than not. Now, later on today, I'm going to cover the different things that determine whether something's elastic in demand or not. But needs versus wants is one of those items, right? So things you need. So I always like to use the example, you guys watch Total Recall with Schwarzenegger, and he's on Mars, and the Martian colony lives in a dome. When the evil corporation or government, I forget, it's been a while since I've seen the film, but when that evil group of people turns off the airflow to the people, how much do you think air would have sold for as you're dying? Or imagine you're at the bottom of the ocean, you're, a quarter-mile deep, which is pretty far down. You don't even need to be that deep. And all of a sudden you realize you have a fairly sizable hole in your oxygen tank. And there's no way you can get to the surface. Well, if I have a store that sells oxygen tanks underneath the ocean floor, how much are you guys going to be willing to pay for that tank? A lot. And let's be honest, you're going to pay whatever I have relative to how much you have, right? So let's take the other extreme. And we call this, by the way, perfectly inelastic. So this is a perfectly inelastic demand curve. Now let's take the other extreme. What type of good do you buy where the price, and I want you to think about what this means. If the price goes up, are you going to buy more? In fact, what this curve's really saying, and some of you might need to think about this for a bit, but what you're really saying when you have a demand curve like this is, if the price goes up above this price P bar at this point, you're going to stop buying. Your purchases would go to zero. And if the price goes down, well, you're happy with lower prices, and so at that price, you're not going to purchase just a little bit. You're going to purchase as much as you can afford up until your budget constraint would stop you from purchasing. And if you have no budget constraint, you're going to purchase an infinite quantity. So we're thinking about it this way. Price goes up, you don't buy anything. Price goes down, you buy an infinite quantity. As long as you're at P bar or lower, you buy the same amount, as much as you can get. What types of goods represent perfectly elastic demand? So what types of goods are we going to find that end up representing perfectly elastic demand for us? Let's scoot this over so you get a better view. So this one's also a little hard, and we have to come up with some arbitrary situations in order to define what's going to really happen here. Because it's not, just like this isn't very realistic at perfectly inelastic demand, this isn't very realistic to happen in real life either. So what types of things do you buy and you say, you know what, I've got a threshold value. If the price down here, I'm going to buy an infinite quantity or as much as I can afford. Price goes up, I'm not going to buy anything at all. And there's really not many things like that where you say, oh, I'm willing to buy whatever. But we can think of a few things, right? So maybe the easiest way is to start with something that's not necessarily a fair metaphor for the situation because it represents something a little different. But let's say you go to the grocery store and you already have it in your mind, I'm going to buy 4 cans of green beans. And you get to a grocery store and there's all sorts of different manufacturers of green beans. But let's say that you believe that all of the manufacturers have the same green beans inside the can. Now you guys have seen this. What are our options in terms of green beans at the store? We have some generic green beans or the house brand, manufactured by someone and relabeled with, Sunnyside Select for S-Mart or whatever Safeway's brand is. What is Sam's Club? I forget what it is, Sam's Choice or something like that. Then you have like Del Monte. You have maybe, what is green beans? Oh, Green Giant. That's another good one. So maybe you have a preference. Maybe you'd rather have the picture of Green Giant in your house, but you're not willing to pay more for Green Giant. So if all of the cans of green beans are the same price at $1 a can, you're going to buy 4 cans of the one with Green Giant. But if the price goes up, are you going to buy any for Green Giant? Are you going to buy any cans? No, you're going to swap out to the old cans at the normal price. Normally what we like to say is perfectly elastic curves represent extreme wants. But as I said, we'll get into more complex stories that determine whether something's inelastic or elastic. There's more than just needs and wants. There's actually different things that are determinants of elasticity. So this is the simple story. So let me erase this and redraw this, and we're going to talk about what differentiates these extremes and a little bit of the math behind it. So we draw our demand curve, and let me make sure that, I'm drawing it a little peculiar here. Let's make it fairly steep. Now that's not perfectly inelastic, but you can see it's steeper than the curve I had drawn originally. And I'm just going to give it up here that this is inelastic, demand inelastic. How do we know it's inelastic? We don't even need to calculate anything. All we need to do is take 2 price points, price 0 and price 1. And we say the price went up. We go over here and we say, okay, when the price went up, what happened to quantity demanded? Here's quantity demanded at 0, and here's quantity demanded at 1. So when price goes up, quantity goes down. This is called the law of demand. Now, I want you to think about what's happening here. Which is bigger, the change in price or the change in quantities? It might be hard to see from your computer monitor, but the steeper this curve gets, so if we drew a curve that was even steeper, what would have happened? We'd have the same change in price, and now our change in quantity would be this little circle right here. So for both of those curves, the percentage change in price is greater than the percentage change in quantity demanded. Probably important to put that D there. And when this happens, we say this is elastic. And there's lots of ways different textbooks label that. You can, my preferred is EP, price elasticity of demand, is how I abbreviate things. But, for the video, we'll just put elastic today. And what are we, or sorry, someone, if I was in class, would have corrected me and said, that's wrong. What are we really defining? Inelastic, sorry. But anyway, this EP still always, for me anyway, stands for price elasticity. Sure, I'll misspell everything. So this is an inelastic demand curve because the percentage change in price is greater than percentage change in quantity. So let's erase. This is where a big board would come in handy because we could just go to a different picture. But let's just do this again. Inelastic curves. What's happening there? Percentage change in price greater than percentage change in the quantity demanded. Okay. So let's draw our new demand curve. Now we're going to do the exact opposite thing, a very flat demand curve. And let's imagine we have a similar change in prices before, although that'd be a little hard because, that big a price change, we might be way out there. So here's our price change. Here's our quantity demanded change. Okay, so once again, price change, quantity change. So what's happening when our percentage change in price is now smaller than our percentage change in quantity demanded? And what we say this is this is elastic demand. Is that clear to everyone? Time for me to shave, but whatever. So let's draw this up here. And we're going to go to the special case. This is a case that I don't really like to teach. It's in almost pretty much every textbook, and it's called unit elastic demand. And the reason I don't like to really teach this, although I mention it like I am now, is because here we have some economic justification for inelastic demand. For elastic demand, we have some economic justification. But for unit elastic demand, there is no economic reason for this to happen. It just happens. So no economic reason is what I'm going to write here. So this is the special case where change in price is equal to the percentage change in quantity demanded. But now there is no economic reason that the percentage changes would be equal. This is purely mathematics. It's because we have to have a dividing line. Now this isn't a very realistic dividing line. In fact, it's fairly artificial. But what would this look like? Bear with me here. But I'm going to put a 45-degree line dotted out here. We're going to pretend that this is 45 degrees. And then we're going to say, okay, let's find a curve that bisects this 45-degree line with right angles, right? Okay. So these end up being, full 90-degree angles, or combined 180 degrees. What we've now done is we've said, okay, this is basically this is going to be correlating with a 45-degree line. A 45-degree line says that for every one unit this way, we have one unit this way. There's correspondence. Well, if that's true, then the same thing is going to be true on this one, which is if we go from here to here, if we say that this is -1, then this ends up being +1. And I know that gets jumbled on these small graphs, so I'm very sorry about that. But this is the special case where the change in demand is percentage for percentage exactly the same as the change in quantity demand is same as the percentage price changes over time. No economic content, by the way. In fact, what I like to say is I think the textbooks are doing a disservice by using a unit elastic demand, because in the real world, if you were an economist and you were what's called an econometrician, a statistical economist, and you were collecting real-world marketing data for firms, you were looking at changes in price and how their consumers respond with changes in quantities, what you would find is that unit elastic demand, you would never report that to your employer. What you would really say is, anything less than 0.8 is inelastic. Anything greater than so if you have a price elasticity of less than 0.8, then you're going to call it inelastic. Anything greater than 1.2, that's going to be elastic. And anything between 0.8 and 1.2 or so is going to be really just normal. right? It's a unit elastic good, or it's just something that really just has no construct. It's nothing special. It's not really elastic or inelastic. It's just in between. But, you know, I can understand textbooks, and the idea is we want to have some easy demarcation points to say where something's elastic or inelastic, so let's use some firm numbers. And if we go with what the textbooks say, which I'm fine with, I just want to point out that reality is different than the textbook, then what's happening here is the price elasticity, EP, is equal to 1 in unit elastic. If your price elasticity is less than 1, then you're inelastic. And if your price elasticity is greater than 1, you're elastic. But I do want to represent that the theory and reality are sometimes different. I mean, you know, in all honesty, you say, I have an inelasticity of 0.99. Do you want to say that that's really different than 1 in the real world? Probably not, if you know what you're doing. So then the question is, how do we solve these problems? What is price elasticity of demand? So this is price elasticity of demand, EP, and that's going to be equal to always the percentage change in quantity divided by the percentage change in price. So you get percentage change in quantity divided by percentage change in price. Are we all clear here? I hope so. So if you have a problem where you're given the percentage changes already, all you need to do is think, and this is what I think because the student told me this a while ago, and it seems to work. You think quarter pounder. Q over P. Quarter pounder is the term that we're going to think of. So I'm going to look over here for something really quick and check my email, make sure no one's like emailing to say I'm off in La La Land talking to no one. And I want to see where I've got something here. So, dirty little secret, a former student of mine took my textbook, because I'm nice enough to loan them a textbook, and I didn't have it, and they never bothered to return my microeconomics textbook, so I operate this class without an econ textbook, but it is what it is. I've used this textbook for quite a while now. So I'm going to look something up, because the last thing I want to do is give you the wrong formula for the midpoint elasticity formula. So it is what it is, but we're going to go ahead and do this. So yeah, so my memory did serve me correctly. So we want to make sure we don't screw this up. So what we end up is the midpoint slope formula being modified to be called the midpoint formula to calculate elasticity. Okay, and first I'm just going to show you the equation. So EP is equal to, still quarter pounder, Q2 minus Q1 over Q1 plus Q2 divided by 2. Okay, we're all on the same page here? All of that is going to be over, so this is our change in Q, percentage change in Q, what we're calculating, over P2 minus P1 over the average price. Make sure you can see that. And you'll find this in your textbook as well. And by the way, that bottom, the denominator, is just your percentage change in price. So it's still quarter pounder, right? We're still doing quarter pounder. It's your percentage change quantity divided by percentage change in price. So let's just apply this to a real problem. You know, hopefully I don't F this up too bad since I didn't come up with the problem ahead of time. But you guys don't know this, but in class I never come up with problems ahead of time either. It's easier to work through things. So let's just do that midpoint formula. Just keep it in the back of our mind. So we have the difference in Q's divided by the average quantity change. Over the difference in the price divided by the average price change. And this formula, the only way you really screw it up is you forget which thing belongs where. So let's just take a little graph of demand. Okay. And let's just say we have two prices. We'll make them up 10. We're going to keep the numbers easy, and 5. And the idea is at 10, we're at 5. And at 5, we're at 10. And I'm actually producing a unit elastic demand curve just because it keeps the math simple for me. And really what you want to do first off the bat is to say, this is my P2, this is my P1, and then trace it over. This becomes my Q2, and this becomes my Q1. Now, by the way, does it make a difference which price becomes P1 or P2? As long as whatever price is P1 traces over to a curve and goes down and becomes Q1. The biggest place people screw this formula up is by not specifying, by screwing up which one's P1, which is P2. This P2 has to have this as Q2, not Q1, right? So if we substitute in, then we get an elasticity of price, price elasticity of demand, and we say the quantity change, the difference, so 5 minus 10, Q2 minus Q1, over the average price change, which is 5 plus 10 divided by 2. All of that over the prices. So we've got P2, 10, minus 5, over the average price change. I wrote plus 15. Plus 5, divide by 2. And let's start solving. So we get negative 5 over 15 divided by 2, so 7.5. And we get 5 over 7.5. Okay. Are we good there? And if we flip all this and solve, what we eventually come to is that we get to negative 1 being the answer. So the price elasticity of demand is negative 1, which we said is unit elastic demand. Now some of you might say, well, why is this not negative 1? And I'm just going to tell you the bullshit answer everyone's told me, which is in economics, we're really doing this. We're taking the absolute value. Price elasticities are of demands and supplies are always, well, demands in particular are always absolute values. And the reason being, because the curve is negatively sloped, we end up with all elasticities are negative, and that's a function of the law of demand. As price goes up, quantity demanded. Price goes up, quantity demanded will go down. Price goes down, quantity demanded will go up. Okay, so price elasticity and demand are always negative. If we represent them as the absolute value, then we can judge the inelasticities a little better for some people. And so price elasticities of demand by historic convention, bullshit answer, are always represented not as negative numbers in most textbooks, right? Some textbooks, the authors are saying, hey, why are we making students learn our crap that's from history? Why don't we just do it the way a mathematician would do it and either put the absolute value sign or represent inelasticities as what they really are, right? Which is, you know, less than negative, or sorry, that'd be greater than negative 1, negative 1, and less than negative 1. But it does throw everything off. The signs all get flipped. So, you know, kind of ignore that because this is easier and historically been done. So the one thing we do, always just represent our value as an absolute value. The absolute value of negative 1 is equal to 1. So now we have our answer. So that's how you calculate the midpoint slope formula. If you end up knowing one of these, the percentage quantity change, but you just have price changes, then you can just do the top or the bottom half and insert in the percentage that's already been calculated for you. No reason to do the work again normally. So price elasticities of supply and demand are easy. And by the way, as I said, the math is exactly the same. And whether something's inelastic or elastic is the same mathematically. But when we move to supply, the interpretation's a little different. So let's just look at the interpretation difference, since the calculations in math are pretty much the same. So let's do two extremes. Perfectly vertical supply curve, what do we call that? Hopefully you're saying inelastic. Perfectly horizontal supply curve, what do we call that? Hopefully you're saying perfectly elastic. So the question is, what is the economic interpretation of these two things? By the way, the math interpretation is the same. We're going to have this number be very close to 0, right? Especially as it goes vertical, it goes indeterminate. And this number is approaching infinity as the curve gets flatter and flatter. So the math is the same, especially when we take the absolute values. So the question is, what types of goods sell where the price changes and the firm says, well, we're not going to supply more? This one's actually hard for a lot of students to get. It's not needs and wants anymore. In fact, what determines price elasticity of supply really is the nature of the cost structure of the firm. There is no simple answer. You have to think about it a lot of times. But I like to summarize down and say that what's really doing this is planes, trains, buses, and last but not least, venues. In this extreme example, because one of the things we'll learn later in the semester of microeconomics is that the supply curve represents, this supply curve, all supply curves are equal to the sum of the individual marginal cost curves for firms, which a lot of that will go in one ear and out the other. But when we hear it again and see it later, it'll make more sense. So what we're saying is the supply curve represents the minimum cost to bring the item to market in a perfectly competitive economy. So when we're talking about planes, once you have a plane, what's the cost of bringing one more passenger on that plane if it's not full? The cost is really inconsequential. In fact, you say, look, if I have a plane that seats 300 people and it doesn't cost me, we can say fuel costs and things like that. That's why nothing's perfectly vertical. But it doesn't cost us anything to, it doesn't benefit us to have an empty seat. And so as long as someone's willing to pay for the additional cost of fuel, the additional cost of a pack of peanuts and some pretzels, or whatever they're given for free on the airline, then the airline should sell them a ticket. What's the value to a concert of having empty seats? In fact, we could argue that empty seats mean that there's less value to the concert goers. And there are concerts where if they're not filling up, especially for high ticket things, they'll pay people or they'll give away free tickets to get people in the audience so that the poor schmucks who paid full price feel like they really were getting value for their ticket, because the last thing you want to do is pay $500 for a concert ticket, go see the concert, and then go on Twitter later that night and say, my God, here's a picture of how empty the concert was. Don't pay $500 unless you're desperate, right? So you want a full concert venue. And so what do they need to charge for those tickets? Well, they need to charge close to nothing, because what's the cost of one more person being in a concert venue? The concert venue has seats for 500 or 5,000 people. If they add a person in, it doesn't cost them anything else. But at a certain point, there is no more supply. And what we're really saying is, past this quantity, we can't go past here. At least not without introducing more costs and changing the supply curve. So we need to buy more planes, build a new venue, things like this. But in the short run, those things are difficult, right? And so this is a very particular instance. So we say planes, trains, buses, and venues. What type of firm would have a cost structure where the quantity they produce doesn't depend on pricing? It doesn't depend on the amount of money they can receive. I mean, what we're really saying here is, it's almost the exact opposite of before, but if this is P bar, if the price goes down, you provide zero supply. As the price goes up, you're willing to supply, within reason, not in the real world, but theoretically, infinite supply. So what types of people sell things where they have a certain amount of costs they have to cover? Once they've covered them, everything else is pure profit, and they'd be willing to sell anything at that price? Well, the answer there tends to be pills, not all pills, but some pills, right, or meds, and software. I want you guys to think, what's the cost? In fact, this is more artificial. This is not as flat as this one. But what's the cost of distributing one more copy of Minecraft on the internet? It's very close to zero. So once you've covered the cost of getting the software to market, the software manufacturers say there's no more cost to me to sell you another copy. Same thing for pills, right? Once we've covered the cost of production of the pills, the cost of producing one more pill is very close to zero. By the way, same thing's true for electricity. As we get out there and we produce more and more electricity, we find the costs fall. And we'll talk about that story later in the semester. Now, as I said, perfectly inelastic and perfectly elastic are there's not many goods like that. But there is a good we can talk about which represents a little bit of both and not a lot of in between. So what do you think the supply curve looks like for agriculture? Agriculture is an interesting good because at low quantities of production, as long as the farmers get enough money to pick the crop, they're willing to take losses as long as they can cover the cost of picking plus a little bit of their losses. Farmers will pick. So sometimes, a few years back, the price of tomatoes plummeted after there was that big problem with tomatoes and there was a shortage. A year later, a lot of people grew tomatoes and there was this glut of tomatoes. And in the Central Valley, you'd see farmers that let the whole field go under and they just plow it under. Why? Because the cost of picking tomatoes was higher than the cost you could sell them for. But as long as you cover certain minimum costs, the farmer's going to bring it to market, and they're willing to bring pretty much everything to market. Now, eventually, the farmer hits the point where they have this choice. For most crops, once it's been picked, with something like corn, they're willing to provide all of their corn until they run out, and then the supply curve is perfectly vertical regardless of price. You can't make more corn out of the field after it's been harvested. But in other crops, it's a little more gradual. Maybe with tomatoes, you're willing to supply this much, but if people are willing to pay you more, you do a second picking, right? You go through and you repick. And you repick and repick, but eventually there's no more picking to do. And you end up in agriculture with these very, kind of L-shaped or, angular supply curves. These are weird supply curves where they're perfectly elastic, and then when you reach the size of the crop that's available, they go perfectly vertical. So anyway, that's one of those special goods that embodies a little bit of both. But most goods are somewhere in between, right? But it's really the cost structure. It's not as easy to determine elasticity for these items, okay? So let's erase this, and I said the one last thing we cover is the elasticity, the determinants of elasticity. And we're going to do it for of demand. I'd love to do this for supply, but I'm going to be honest, I haven't spent a lot of time looking, but I've never found a quick and ready list in the same way you do for demand in textbooks or online or anywhere. In fact, when I learned price elasticity of supply in a lot of textbooks, they don't even cover it, because really it is about the shape of those marginal cost curves and what the marginal costs for a business look like. And at this point in class, you don't have as much technical information. I tried to give you an idea of what it looks like, but a lot of that will make more sense for price elasticities of supply later on. So when we talk about determinants of demand, we can say needs versus wants. We already did this one. And the idea is, and we're moving from inelastic on all of these, we're moving towards elasticity. Okay. Another way some textbooks put this is needs versus luxury items instead of wants. The next thing is time is a determinant of elasticity. And the idea is less time versus more time. By the way, this is my crappy rendition of a clock. So we're going from inelastic to elastic. So the idea here is, let's say that that the price of gas goes up. Let's imagine that you're at work today, and while you're at work, some nasty crap happens in the world, and the price of oil spikes up, and you leave work, and you got to work, and you needed gas, and you're like, oh, it's okay, I'll just get gas on my way home. You know you can't get home without getting gas. And so you go and you run by the gas station on the way home, and unbeknownst to you, because you're like most Americans and don't listen to the news, you turn on go past the gas station, and you're like, holy crap, gas is $15 a gallon. Now, I guarantee you're going to buy some gas today because it's a need and you don't have time to adapt. But by tomorrow, are you going to find a bicycle to ride to work? Or are you going to find someone to share your ride with? And then as time goes on, are you going to say, hey, maybe I need to buy an electric car and swap out of my SUV? So the more time we have, the more adaptable we are to change. The next one is share of the budget, and this one's not very good, but it works. Some of these are more important than others. And some of these can happen in varying ways and play off each other to influence elasticity. But share of the budget, the idea is as you spend less on something, it's more inelastic versus spending more of your budget on something. Now this is hard because some of the things we spend most of our budget on, like housing and electricity and gasoline, are inelastic because they're needs. And we can say that the needs trump the other. But let's imagine that you have two things you purchase and you allow yourself to buy 20 video games a month. I don't even know if 20 video games come out, but let's say you buy 20 video games a month. The argument is, if you're buying 20 video games a month, that's a lot of video games. It doesn't hurt you psychologically. It doesn't make you feel worse, and we'll talk about this in consumer theory, to purchase less video games. Likewise, if you're spending less of your money on video games, and you only buy one video game a month, what's it cost you to give up that one video game a month, the one fun thing you do? It's going to cost you more. And so the idea is, as you consume more of your budget on things, then it's more elastic. It's easier to give up parts of that budget. If you only spend $5 a month on coffee, giving up that last cup of coffee a month or latte is going to be difficult. So we've got needs versus wants, time, share of the budget. Those are the hard ones. There's two more I'm going to let you guys track down and tell me what they are. If you can't find it, just put it in office hours and I'll tell you the answer. But there's two more you guys can track down. Those are a little easier to discern on your own, right? But this in particular is the one people script the most. Well, I'll let you guys figure it out, but definition of the market's another one. And by the way, that's a hard one in some ways, but I want to see where you guys can figure out what's the less to more on this one. And then, and by the way, less to more, smaller to greater, maybe. Okay. Make sure, I check my email, make sure nothing's going wrong with my webcast. You guys have been pretty good about telling me when something happens crazy. Okay, so you guys can determine the last one because we do have a lot to cover today and I'd like to get some more stuff done. So there are other types of elasticity that are covered, but price elasticity of demand, price elasticity of supply are about how steep the curve is. When we look at cross-price elasticities, the math is pretty simple. And cross-price elasticity, sure, I'm misspelling everything today, is really about a change, a shift in the demand for a good. And it's the story of complements and substitutes that we've already learned. Okay. When we look at income elasticity, so this is going to be the price of one good percentage change in price of one good relative to the percentage change in quantity demanded of another good, Y. And by the way, I flipped this. Sorry, a quarter pounder still quantity over price. My fault. You guys can rewrite it. Then we've got income elasticity, which is how you respond to changes in income. Once again, another one of these. Changing demand curve. It's just another way. I don't know, still butchering the language. Here we're looking at what happens when your income changes or wealth effects. So we say percentage change in quantity, and I might have this backwards, demanded divided by the percentage change in income. And we'll use Y for income. But I'm running out of time because, as those of you who watch every week know, I have to go get my kindergartner for another, well, this week, next week, and the following week. So the next 2 weeks, so all the way through to week 6, and then the last 3 weeks I'm free in here all afternoon because he gets to go full day at that point. So we do need to do something with taxation. So first off, Google's your friend on taxation issues. If you're not good with what the different types of taxes are, go ahead and just look it up on Google. It's a pretty good resource there. Wikipedia is fine on this topic. I know some instructors don't like people to use Wikipedia. I'm not one of them. I don't care. Now, I like to say in my class, in the homeworks, taxes can impact consumers or the producers. I always, in my examples, only have taxes impacting consumers, or impacting producers. And the argument is, when we look at purchasing goods, so this is our initial condition, and let's say this is the market for orange juice. But when we look at our initial conditions, what is it, who pays taxes? You pay income taxes, but who pays taxes when you pay taxes on goods? It's really the producers, right? You might pay the tax to a producer, but the person who writes the government the check for most taxes is a firm, right, other than income taxes. And by the way, even for income taxes, unless you're self-employed, most of you, your company takes the money out and sends it to the government. You don't send the government money. So I like to say that by assumption, at least in the American economy, taxes always impact the supply curve primarily. You can do on your own, and some of the homework problems ask you to do a demand curve shift. Nothing's changed. Okay? So let's say we're going to deal with the simplest type of tax. We could tax the price of the good. That's called a sales tax as a percentage of the price of the good. But we're going to do something called an ad valorem tax. Ad valorem taxes are where the quantity is taxed. This is like gas taxes. So let's say orange juice is taxed per half gallon sold in the grocery market. And so the question is, what's going to happen? Well, if taxes go up and the orange juice company has to pay more taxes, then the supply decreases. And we say that the supply curve is going to shift up relative to that tax. And the best way to do this is with some problems. I actually don't think this is the hardest topic in the world once you have basic supply and demand theory down. I think elasticity is much more difficult to wrap your head around. What's difficult here is we know that the change is going to be that we get this new quantity, or sorry, this new price in the marketplace, and we get this new quantity that's out there in the world. Now, the big thing that throws students off is this idea of something called incidence of tax, which is who pays the taxes. Okay, so who's going to end up paying taxes? And the idea is, what's the real price of the good? Well, the problem is, if the tax was, let's say that the tax is $1. Okay, and let's say that this right here would represent a $1 change. So this blue line is P0 plus 1. Now we can see that the red P1 line is smaller than that, right? What that means is the price of the good doesn't go up for $1. And a lot of
emailed you yesterday.
Oh, no problem, no problem. Hey, can I call you back in 2 minutes?
Yeah, of course.
Okay, call you right back.
Alright, thank you.
So, figured that was a student call, and it was, but we'll handle that in a second, because I had someone make an appointment. One of the other reasons I started slowly. I thought they were calling at noon. But anyway, so what's going to happen is the price goes up, but now does the firm get to keep price P1? No, the firm has to still pay the government $1. So the firm gets more money out of the customers, but they don't get the full $1, right? They give up some of that $1. So what we can say is here is the price the firm receives. And here's the price the government gets, is that $1. And so the government collects this whole rectangle in tax revenue, and the firm gets to collect everything below that in firm revenue, okay, just like normal. And the consumer surplus, if you're interested in that, I don't know if you guys are that far along, is everything above the price line. So the green area ends up being consumer surplus. The blue area, everything below the price line and above the supply curve, ends up being producer surplus. And this area in here ends up being tax revenue. Now, if you were looking ahead, this area right here, the triangle right here, becomes what's called dead weight loss. That's our dead weight loss in the system. It's the amount of money that is no longer kept in the system because of that tax. And it's represented as an efficiency loss. So anyway, the video's been long enough. I don't like to go more than an hour because it gets a little heady, and also I need to return this student's call. But for tax incidents, if you have any specific questions, feel free to put them in the office hour forum or give me a call or text or something. I can do another video, but I'd like a little more guidance from you guys, what you guys want me to give you in terms of that. Because, you know, tax incidents, as I said, I don't view this as a necessarily complex topic area, but it is something that can be difficult in certain areas. But it's something that's definitely workable and manageable. And if you remember that if without a perfectly vertical curve, that people do alter their supply and demand as the price changes of a good, right? And so that law of demand and the law of supply kick in. And they're very important features for who ends up paying the tax. So what you'll find, long story short, in a lot of textbooks is the discussion that if you have inelastic demand curves, right, where people need things, then consumers end up paying most of the tax. If you have things people want, like potato chips, and you put in place a snack tax, then the producers end up paying most of the tax. So as I said, any specific questions? And you guys can draw those elasticity curves and then draw the same graph I did with different slopes, different elasticities. Make the demand curve more inelastic, make the supply curve inelastic, make the demand curve elastic, the supply curve elastic. See what happens to that tax incidence over time and with different curves, and you guys can see what the results are on that system. So anyway, if you guys have any questions, feel free to call as always, and I hope you enjoy this hour. Talk to you guys later.